In this video, we're going to cover the skill of multiplying a two-digit number by another two-digit number, and we're going to use partial products and area model to help us solve those problems. So reminder, when we're doing area model, we're actually going to expand both of the numbers in that multiplication number sentence. So I'm going to practice that by doing 53 times 28. I'm going to expand out 53 to 50 and 3 above the boxes. And then I'm going to expand out 28 by doing 20 and 8 to the side. So now what I'm really doing is I'm just pinching my fingers together for both side lengths of the square, and I'm multiplying those two together quickly. I know 5 times 2 is 10, and then using my shortcut of adding the zeros, 50 times 20 is 1,000. When I pinch my fingers together here, I'm doing 3 times 20. 3 times 2 is 6, add 1 0. Here I'm doing 50 times 8, which is 5 times 8 is 40, add a 0. And then the last box, when I pinch down, I'm going to get 3 times 8, which is just simply 24. Then with those 4 boxes, I'm actually going to stack these in order from greatest to least. So 1,000 is my greatest number, and then it looks like 400, and then 60, and then 24. And I just add these together. And that's going to get my answer for this multiplication problem. For partial products, we're really doing the same thing, except it's just going to be stacked a little bit differently instead of using a square model. So I'm just going to take my 8 and multiply it by both of the values of the top number of 53. So I'm taking 8 times 3 is 24, and I just write that answer down below. Then I'm going to do 8 times this 5, which has a value of 50 because it's in the tens place. So 8 times 50 is 400. Then I'm going to do the same thing, but this time with the 2, which has a value of 20. So I'm going to do 20 times 3, which is 60. And then 20 times 50, which is 1,000. So again, I have these stacked and I can just solve, getting my final answer of still 1,484. Same answer, 2 different ways to solve for this two-digit by two-digit multiplication. Now I'm going to use both of those models when it comes to a word problem. A gardener is planting flowers in a rectangular garden. The garden measures 24 rows of flowers with 16 flowers in each row. How many flowers will the gardener plant in total? So I'm going to be doing 24 rows with 16 in each, so that's going to be a 24 times 16 problem. To set up my area model, I'm 2 digits on the top, 20 and 4, expanding it out, and 2 digits on the side, 10 and 16, expanding it out, and then I can just do my quick grid. And then I'm going to multiply by pinching my fingers in, so 20 times 10, 2 times 1 is 2, add 2 zeros. 4 times 10 is 40. 20 times 6, 6 times 2 is 12, add 1 0. And then lastly, 6 times 4 is 24. Stacking those together here in order from greatest to least. And then I can quickly add these up to get 384 flowers. Now, if I did this correctly, I should get the same thing when I do partial products. For this one, I stack it just like I would any addition or subtraction problem, lining up my place values. But this time I'm going to solve for the 6 times the top 2 values. So I have 6 times 4 is 24. 6 times 20 is 120. Now I need to do the same thing, but this time with my 1, which is a value of 10 because it's in the tens place. So 10 times 4 is 40. and 10 times 20 is 200. So then I add these up, and again, get that same answer of 384 flowers. 2 ways to solve, same end answer.